as we get into Chapter 7, we are going to be taking the integral of many, many different functions. We are going to start out with some pretty basic integration techniques, and then we're going to move to some more interesting integration techniques. Our whole goal will always be to evaluate the integral without the use of a calculator. All right, the first lesson we're going to start with is just some basic integration techniques, especially techniques 1 through 5 are mostly ones that you have seen before. It's just a good refresher. So at the end of this lesson, you'll be able to evaluate an integral using basic integration techniques or tricks. All right, our goal is always going to begin to know how to recognize how to begin an integral problem. Mostly we've had so many different ways that we evaluate integrals. How do I get it started? Few questions you can ask yourself as you're getting started on the problems. Can you simply just take the integral? Sometimes we kind of forget that there's just a simple integral that we can take. Or is there a formula I can use? Is there, like if I see integral of secant tangent, I know that my answer would be secant. So try those simple things first, and then if those simple things don't work, we can go a little bit deeper. All right, so we're just going to start with some tricks. Trick 1, I'll call it, would be a simple u substitution. We've done this many times, but this would just be one. If I can't just take the integral right away, the first thing that I'm going to look for is, can I do a u substitution? And I notice that yes, definitely I can. So I'm going to let u equal 16 minus x squared. And then I notice that my du, the derivative of 16 minus x squared, will be negative 2x dx. And I notice that I have a 5x there. I really want negative 2x. So if I multiply by negative 2/5 on the inside, that will equal negative 2x. So I would need to do negative 5/2 on the outside. So now I have negative 5/2 integral. I now have up top, this all becomes du. And down below I'll have u to the 1/2. So before I evaluate this, I'm going to go ahead and rewrite that as u to the negative 1/2. du, and some of you might have decided to do that right when you started the problem, and that's fine. And now I'm going to go ahead and evaluate the integral. The integral of u to the negative 1/2 would be 2u to the positive 1/2. These 2's are going to cancel out, so I'll be left with negative 5 square root of u, and then replacing my u back in, I'll have negative 5 square root 16 minus x squared plus c. So we don't want to make the problem harder than we need to. If we can do a u substitution, go ahead and do one. All right, one thing we can do on this one, if you were to try a u substitution, you would definitely notice that du is not there. But what I can do, and I've got parentheses and something is squared, we can go ahead and expand it to make the problem workable. So this is really 1 plus 3x squared times 1 plus 3x squared. So if I FOIL that, I'll get 1 plus 3x squared plus 3x squared plus 9x to the 4th. If I simplify that, I'll have 1 plus 6x squared plus 9x to the 4th. And since there are plus signs, I can actually evaluate each integral separately. So when I do that, I'll get x plus 6/3, which would be 2x cubed, plus 9/5 x to the 5th, and then plus c. And voila, we're done with it. Okay, another trick that we can use is an inverse trig rule. First thing, definitely I would try to see if I can do a a u substitution. I can't, because du would be an x, and there's no x up there, and we're not allowed to put variables in our problem, only constants. So I do notice that this is a trig problem. If you're familiar with your trig rules, I know that that's looking like this square root of a squared minus u squared. Well, that's what that formula looks like, and I know that the integral of that is going to be arcsine of u over a plus c. So since I recognize that that's what I have, first of all, I'm just going to bring my 5 out front so it's not in the way. And then when I'm doing my parts for this to make sure that I've got it, my a value will be 4 because a squared is 16. My u value would be x because x squared is my u squared. And then du I also have to check is going to be 1. And notice I have the 1. So since all of my parts are there, I'm ready to just go ahead and use my formula. So my answer is going to be arcsine u over a, which is going to be x over 4 plus c. And then I'm done. And if you're not sure of your inverse trig rules, I'm just going to quick write them. The second one would be du over the square root of u, and then u squared minus a squared. If you see something like that, this is going to be an arcsecant. It's going to be 1 over a, arcsecant, absolute value of u over a plus c. So if you do see something like that, we can use that. And then the other one that we do have is du over a squared plus u squared, and if we have something like that, that's going to be 1 over a of arctangent u over a plus c. So those will be very helpful as you're doing inverse trig rules. If you notice something that looks like that, then you can apply the inverse trig rule. All right, and then completing the square, we did this a while ago. Again, if I tried to do a u substitution, du is not there, so I can't do that. I do notice that I do have a trinomial. I have something with an x squared and an x in it, which means I'm going to be able to actually turn this into, I think we'll turn it into an arctan problem, so we'll try to turn it into an inverse trig problem. The way that we're going to complete the square, if you recall, I think we maybe did a video like this, but I'm not sure. We're going to have x squared minus 8x, leave yourself a space, and then put your plus 25 on the outside. We're going to take the middle number, divide it by 2, which would give me negative 4, and then square that, and I'll get plus 16. So plus 16 goes on the inside, minus 16 goes on the outside, so then I'm left with 1 over x squared minus 8x plus 16 plus 9. And then I know that that factors, it's going to be 1 over x minus 4 squared plus 9. And then I notice that this is an arctan problem, so we can actually go ahead, and I'll just rewrite that formula again just in case. A squared plus u squared equals 1 over a arctan of u over a plus c. So when I do this one, my a value will be the 3. Notice the a is the constant, even though I have it written backwards. A would be 3. My u would be x minus 4, because it's the part without the square. And then I do need to check for my du. The derivative of x minus 4 will be 1, which is right there. So I'm all set to go ahead and fill in my formula for arctan. So this will be 1 over a, so it will be 1/3 arctan of u over a, which would be x minus 4 over 3, and then plus c, and I got it. So those are the first formulas that I can use to evaluate integrals. Oh, and we're going to do one more actually. How about separating the numerator? The trick basically is exactly what it says. If I do a u substitution, there's actually too much there. So separating the numerator, if there's a plus sign up in the numerator, I can separate the integral into 2 separate integrals. So I can make this x over x squared plus 16 plus the integral of 9 over x squared plus 16. So now I have actually 2 different problems to do. In this first one, I notice that I can do a u substitution, so I'm going to let u equal x squared plus 16, and then du will equal 2x, and I do notice that I have x, but I need a 2, so I'll put a 1/2 on the outside, so I have 1/2, and then this 2x turned into du, and the x squared plus 16 is u. And if you recall, the integral of du over u is natural log, so this will be natural log of u. And then for my second integral, I notice that this looks like, especially because 9 is a constant, that I can do an inverse trig, and this one would be tangent, arctangent again. I'm going to pull the 9 out front. And so I'm just checking my parts. My a would be 4, because the a is always a constant, remember. My u will be x, and then du, the derivative of x, is 1. So I have all my parts there, so I'm ready to evaluate this. I can't forget to bring my 9 along for the ride. And then from here, it's 1 over a, so it will be 9/4 arctan u over a, so x over 4, plus c. So this, in its entirety, would be my answer. One thing that I'm actually going to go a little bit farther, if I have a 1/2 sitting out front of the natural log, I can actually bring it up and make it a power, and anything to a 1/2 power is a square root. So an alternate way of writing that answer, especially if it was the answer in a multiple choice question, I could rewrite it as the square root of x plus 16, and then plus 9/4 arctan x over 4, and then plus c. And now we're done with the first integration tricks.